This class is about interaction of X-rays with matter. So what happens when we have our X-rays from the tube and they hit the sample that we want to analyze. This series of class will give just a basic information, but these are the basic concepts that help us to navigate the XRF spectroscopy basics. X-rays are part of the electromagnetic spectrum. We use the electromagnetic spectrum for the visible light, so we detect it with our naked eyes, and then we use the infrared spectrum and the ultraviolet spectrum. We use them in art examination, where we do basically over here, using this range, we use the technical photography camera, and when we go further into the infrared, we use the infrared reflectography, so generally we use an InGaAs camera. This part of the electromagnetic spectrum is described using nanometers nm. We say that the infrared is from 700 nanometer toward 1700, the UV is between 400 nanometer 350 nanometer. X-rays are also part of the electromagnetic spectrum, so they are photons, such as the visible light photons, but their energy is much more. In general, we can indicate the photons using the wavelength, the frequency, or the energy. We use one of these three units depending on the spectral range, because it could be more or less convenient. So in the case of the X-rays, we are going to use this unit keV, kilo electron volt. This is a unit to indicate the energy of the X-rays, and is more convenient because we can work with this small number. Basically, the X-rays that we are going to use for XRF spectroscopy are between 1 keV and 50 keV. So let's introduce the atom structure, a very basic level, but enough to understand XRF spectroscopy. An atom is made of a nucleus where Z indicates the atomic number. This is the actual number of protons inside the atoms. So could be just one proton, so we are going to have hydrogen. We can have two protons, so we have helium, and so on. The number of protons, Z, define the name of the element. So if we have two protons, we have helium. If we have three protons, we have lithium, and so on. These black sphere over here are used to indicate the electrons. Around the nucleus, the electrons will be rotating. We can imagine them as orbiting around the nucleus. They occupy some orbit, specific orbit. The closest one is the K shell. These orbits are called shells. The closest one is the K shell. Then we use this nomenclature. We have the L shell, the M, the N, actually there is also the O shell. Now we look into what happens when we send X-rays into a sample made of some specific kind of atoms. So in this case, we have this red one with this wavy line is the photon, the X-ray. The first effect that we discuss is the photoelectric effect. This happens when a photon, particularly an X-ray, can kick off an electron from the inner shells, generally the K, then the L and the M. this electron absorbs this energy from the photon and is kicked off from the atom. Another effect is the Compton scattering. We have here the X-rays. This effect happens with the external electrons of the atom. The X-rays goes into the electron. This electron is kicked off, so goes away, is emitted from the atom, and the X-ray is still here but with less energy, because some of its kinetic energy has been given to the electron, so the electron can be emitted, but the photon has still some energy, so we will see basically X-rays with less energy. And this is the Compton scattering. Then we have the Rayleigh scattering. This again happening with the more external shells, the electron in the more external shells. In this case, we have that the X-rays interact with these external electrons, but the X-rays is just, let's say, reflected back. So it bounces off the atom, maintaining the same energy. So you can imagine it's like a mirror with visible light. The light goes there and maintains its energy, its color. We send red light, and from a mirror the light is reflected with the same color. This illustration summarizes all the three phenomena that we described. So we have the photoelectric effect, we have the Compton scattering, and the Rayleigh scattering. These three effects are present in our XRF spectra. So this is very important to understand this basic phenomenon, at least with this basic introduction, because we can then understand what's going on in our XRF spectra.